Hello, today I'm going to show you how to use a script that was written as part of my postdoc named Forest to align co-register LiDAR data with multiband images. Specifically, this example is a fusion between the digital elevation model of the LiDAR that was created using LiDAR data and the open source software DASOS, and the near-infrared and the red band of the Sentinel-2 images. So I'm quickly going to show you how to create some metrics from DASOS. So it's a command line software, so you can write dasos.exe. There is an executable version on GitHub, and the link of the software is available below in the description. First, you need to define your input file. So this is my input last file. Then you need to specify that you want to create a metric. Then you type the type of the metrics. Height is similar to the digital elevation model, but it relates to voxels. You can read more information about it in the user guide of the software. And then you need to type a directory and the name of the file that you want to export. For example, this is my H21 ASCII. And the software start show you how much it's progressed, and when it's reached to 100%, your metric is ready. And we can create multiple metrics for each flight line that interests us. So the script that is been developed, it takes as input a directory with multiple maps that we created. It takes a TIFF image, a TIFF geo image, and then an output directory, for example the red band, where it outputs an ASCII, well, it outputs a matrix in ASCII format, one matrix for each of the input file. So we have images like Sentinel-2 that is not in TIFF format. We can use NAP to convert them. This is an example. I can use the graph builder. Go to raster, data conversion, band select. I also use the reproject command because we need to make sure that the input files, the ones exported from DASOS, and the ones and the TIFF image are in the same coordinate system. So that's why I'm using the reproject one. So it reads the JP2 image. We only want one band, so this is band. So this is band 1. The project, I'm not doing anything because in the example I'm using, they have the same coordinate system, but if they don't, you need to make sure that you change the coordinate system. And then I choose where I want to export my new image, so I'll save it in my documents and I run. And once this is finished, your image is exported. So the script implemented during my postdoc is available on GitHub. The link is given below in the description. If you go to the main.py file, there are instructions on how to use this script. As mentioned earlier, it takes as input a directory that contains many ASCII metrics exported from DASOS, a GeoTIFF image, an output directory where it outputs all the metrics that they are co-registered and aligned with the ones created with the LiDAR data. Once we run the metrics, we have co-registered metrics for example, the near-infrared band. For each file from the height map, for example, or any other map that we want to create from DASOS, the software automatically creates one file for each one, for each corresponding one. So in this example, I created, I got the red band and the near-infrared band. And as you may notice, now we have one ASCII file for each band, and we want to fuse them into one to get this example. In order to do it, we can use GDAL. With GDAL, we can create a virtual raster that will merge the three bands. So we write GDAL, we use the command separate. First we give the name and directory of the output file, the one that will have both RGB images, and it has to have the extension of VRT because it's a virtual raster. Then we put the directory. Then we put the directory in the name of the red band, then the green band, and then the blue band. And this will create a virtual raster. As you notice, I put the TIFF images, and this is because the GDAL command requires the input files to be in TIFF format. In TIFF format. As you noticed before, the metrics are exported in ASCII format, but we can convert them using QGIS. So, for example, here are some of the ASCIIs. I can right-click, say Export, Save Image, and I select GeoTIFF. I write the name of the image, which is the new image. And then I just press OK, and it will save me the image. So if we run the script that I showed you earlier, we get a .vrt file, which we can drag and drop into Quantum QGIS. And this is an example of the output that we get, which is a single flight line that it uses the height of the LiDAR data and the near-infrared and the red band as the RGB values of the image. This video is part of the FOREST project, which is co-funded by the European Regional Development Fund and the Republic of Cyprus through the Research and Innovation Foundation.